Hello, welcome to this presentation. My name is Joao Hemptinne, and today I would like to present you how we calculated river widths using watermarks and hydraulic constraints. Here is the content of this presentation. RiverOps is an algorithm that has been developed for the SWOT mission. It aims to calculate river widths using rectangular convex envelopes. But in some areas where the river has a lot of meandering, these envelopes can transform into triangles, and this can affect the precision of the results of the widths calculated. So this algorithm has some defaults, and we wanted to try to find an alternative algorithm that could calculate widths more precisely. To do so, we used different data. First of all, we used watermasks that are maps showing where there is water and where there is not water. In this example, we see that water is in white and the rest of the map is in black. We also used flow direction maps. They are maps, and for each pixel, every pixel has a value that shows where the water will flow in which direction. We have two different sources, Hydraul that has a resolution of 90 meters and Hydraul that has a resolution of 30 meters. And we use also center lines from the global river widths from Landsat database. And a center line is a line that goes from the beginning until the end of a river, always going in the middle of the river. We have to pre-treat all this data before running the algorithm, because as we can see, a watermask has not always the same size and resolution as the flow direction map. So we have to reproject the watermask on this flow direction map to get a new watermask at the same size and resolution as the flow directions. And then we have to reproject the center line on this new watermask, to have a watermask including the center line with the same size and resolution as the flow direction map. Then we give these inputs to the algorithm that is represented here. It is a simplified version of the algorithm, so if you have any questions, feel free to ask me. And here we can discuss about the first result we got. This is a result we got running the algorithm on a Sentinel-2 scene of the Niger River in Africa. We used two flow direction maps, one from Hydraul and one from ALOS. This map is the result with ALOS. So the font of the map is Google Satellite map, and we printed on it a watermask in blue and the widths in different color depending on the value. We compare here the result with ALOS and the result with Hydraul, because as they don't have the same resolution, the results are evidently impacted. We can see it here. With Hydraul, we don't have a lot of variety in the values. We only have 7 or 8 different values, but with ALOS we have a lot more precision. We can see this result again here. When we plot these values as a histogram, in both cases, we have more values and more variety with ALOS and less variety with Hydraul, even if the shape and the distribution of the values is more or less the same. So finally, ALOS being 3 times more accurate than Hydraul, it gives better results. But this is only a first step in our test. We want to test this algorithm on Landsat optical scenes because they have a different resolution than the Sentinel-2 ones. We also want to test the algorithm on SWOT pixel cloud products because we could then compare our result with RiverOps and see if we are more efficient, more precise or not. And we would also like to test this algorithm on different rivers because there are rivers that are really thinner, rivers that are more complex like the Amazon. So it would be really interesting to test in different environments from different sources to see how our algorithm will behave. Thank you very much for listening, and if you have any questions, feel free to ask me.